Hey guys, IE.RVT here, and we're looking at Module 5, Homework B, Tab 2, Part 2, Parallel Capacitors Total Charge. So from the previous part, we found out that C sub t is equal to C1 plus C2 plus C3. And the charge stored in a capacitor is defined by the equation Q is equal to C times V. And for the equivalent capacitor C sub t, the total charge Q sub t stored when connected to voltage V is going to be Q sub t is equal to C sub t times by V. And that's pretty much going to be what you went into Snape physics. But we can go ahead and solve the algebra out just to make it a little bit make more sense in case it's not clicking in anyone's heads. So first we know that each capacitor, so if we denote it by C sub I, where I would be like 1, 2, 3, C1, C2, C3. So for each capacitor, C sub I stores a charge according to its capacitance and the voltage applied across it. Since they are connected in parallel, they all share the same voltage V, right? So now we have to think about the total charge calculations. So the total charge Q sub t in the circuit is the sum of the charges stored in the individual capacitor. So it's going to be Q sub t is equal to Q1 plus Q2 plus Q3. And using the charge formula for each capacitor, it would be Q1 is equal to C1 times V, Q2 is equal to C2 times V, and then Q3 is equal to C3 times V. And so pretty much we can go ahead and express the total charge as being Q sub t is equal to C1 times V plus C2 times V plus C3 times V. And now we can go ahead and factor out that common term V, so it's going to give us Q sub t is equal to C1 plus C2 plus C3, and then times that by V. And so now we can substitute C sub t. And because we know that C sub t, let me write this out, C sub t is equal to C1 plus C2 plus C3, we can go ahead and substitute C sub t into the equation. So then that would get us Q sub t is equal to C sub t times by V. And that's how we got that answer in pretty much more algebra terms. So pretty much this equation shows us that the total charge stored in a parallel capacitor configuration depends on the total capacitance and the voltage applied. And I hope this helped.